Taking the moment about an axis is the same as saying that we want to take the moment about a line. Those two words are pretty much used interchangeably. The formula that we use for this is to take the dot product between the unit vector of that axis or line with our typical formulation for the moment, which is r cross f. R being the position vector and F being the force that's causing the moment. Now, when we actually formulate this into a matrix, what we see is that unlike in the regular cross product, where every single space or direction is available to us in the first line, we are constricted to having an answer that is on this axis. I mean, the whole point of the question was to ask you for the component of the moment that works only about this one line. So that means that our answer can only be on the one line. And so our first line of the matrix will actually be the unit vector components, because that's the only direction that our final answer can act in, the direction of this unit vector. The rest of it is pretty much the same as before. We fill it in with first the components of our position vector, and then finally with the components of our force. Now, once you finish doing all of this, what you'll actually end up with is just a number. Let's just say, for sake of argument, that it'll be 400 Newton meters. Now, why is it that you get a number and not something with I, J, and K components? Well, let's take a look at what this actually looks like in a real situation. Let's say that we have some kind of a pipe attached to a wall, like this. And we have some force, F, acting on the end of the pipe. And what we want to find is the moment about this line here. Let's call it line A. Well, the position vector that we pick, R, can really be any position vector from here to here. So let's just say that that's going to be R. And our unit vector will have to be along A. It is one unit in length, but in the direction of our line or our axis. So this right here is our unit vector U. Well, what's actually happening here is that what we want is an answer for the amount of moment that actually acts in the direction of U, or along A. Which means that our final answer has to be either this or this. It can only be one of two answers. Again, because a moment about A means a rotation like this, in which case we have a positive moment, or like this, in which case we have a negative moment. And that's why our answer can just be a number, let's say 400, with either a positive or a negative sign on it, because it can only be in the direction of the line that we're looking at. Now, let's say that we actually have multiple forces acting on our system. Now, what does that math look like? Well, just like we can sum forces, we can also sum moments. So if we have the sum of moments along an axis, well, this part is the same here, but we just get a sum of moments. So this would look like something like this if expanded out. Let's say we had two forces, F1 and F2. Now keep in mind that these position vectors don't necessarily need to be two different ones. R1 does not have to be different from R2 if F1 and F2 lie in the same place. Now what this can expand into if we want to, is a distribution of our dot product into two parts. Because if you remember anything about the dot product, it's distributive. So basically we just took this and we multiplied it out like that. And if we do it this way, then, well, we just basically get two different matrices that look very much like the one that we had on the top. Whoops, that's X right there. And that's a Z. And of course you can do this with as many forces as you need to. You can have 3 forces or 4 forces. It doesn't really matter. But this is what you end up with. And so the method becomes pretty much the same as what we had before. Now let's say you wanted to do something different. Well, another way to actually solve this problem is to solve the inside of this thing first, in which case you will actually get an I, J, and K component. Let's just put some numbers to it so that it's a little bit easier to work with. Well, if you remember anything about the dot product in 3D space, you'll also know that it's basically just the X components times the X components, the Y components times the Y components, and the Z components times the Z components. What does that mean? Well, let's say that our unit vector is actually, well, 1/2 plus 1/3 plus 1/4, just to make things easy. Well, the dot product here is just this times this, which is equal to 3/2, plus this times this, which is 2/3, and of course this times this, which is 1/4. And that's equal to something too. So those are two different ways that you can actually take the moment or sum of moments with multiple forces.